Okay, so what we're going to do today is we're going to get into chapter 2. We finally finished chapter 1. Chapter 1 is kind of just a lot of boring, uh, just simple definitions, a lot of new phrases and words and stuff that you just kind of have to choke down a little bit. So chapter 1 is a bit on the boring side, but chapter 2 gets a little bit more exciting, and we will see if that's true or not. You can call my bluff. So in chapter 2, we're actually finally concerning ourselves with actual data. Data is just information. That's all it is at the end of the day. It's just information of some kind. Now, it can take on several forms. It can be qualitative data. You can talk about quantitative data, where your data involves actual numbers and the like. So what we can talk about is something called a frequency distribution. Frequency distribution. What happens is you're going to have categories of different things that you're trying to collect data about, and you might have count data. And you can see a perfect example right down here, but we'll get to it in just a moment. And what you can do is you can list the frequency of each of those categories, how many times they occurred. The relative frequency of a category is just how much did that category occur, what was its frequency as a number, divided by how many total things were there, how many total different data points did you have. So a perfect example of this would be a physical therapist is studying the different types of rehab she gives to her patients. She takes a simple random sample of her patients. So the first person she talked to was having back issues. The next person was having wrist issues. Next person, elbow issues, and so on. Well, as you can see, you could have multiple people with back issues. In fact, that looks to be the case for sure. You could have multiple people with knee issues or hand issues. So that's really ultimately what we're going to be counting here. We're going to be counting each of the different types of issue and how often they occurred. And we have this nice little chart kind of already doctored up for us. Now, in order to be able to see it, we might need to do something like that. And now we can annotate. So some of the body parts we're seeing issues with, you can see the back. We can see the back. And real quick, I see someone just entered. Mary Lee Calvillo, hi. Did you, or you can just chat with me in the text box. Are you sitting in the classroom right now? I apologize. It was kind of a little bit of a late decision last night. I got on to check the weather, and oh, okay, you're not. Good. Were you able to see my email and my message? Was everybody in here able to see the announcement on Canvas and the email message? Good. Hopefully that got to y'all in a decent amount of time. Hopefully you saw it this morning, just because it looked like they're predicting storm of the century. So it was just kind of a decision I made last night, especially since everything's already set up for virtual learning. I just didn't want anyone to get into an accident. And if you don't believe me, if you think I'm just being overcautious, I had a student on a flash flood morning who was coming to my 8 o'clock class, and she got into a horrible car accident. Somehow she came out completely unscratched, but her car was absolutely destroyed. And unfortunately, I think the person she got into an accident with, I think there was some light injuries with them. So just playing it cautious. It's not fun driving in the rain, especially very bad rain. But anyways, back to it. So let's see the body part. The first one we see is the back. The next one I see is wrist. Then I see the elbow. I see the back. I see the hip, neck, shoulder, Try to get it in that box there. And then the knee. Okay, so those seem to be the different types of body parts that the physical therapist is having issues, her patients are having issues with. So now what we need to do is just go in there and get some counts. We need to count up the number of times back occurred. So let's see, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. 9, 10, 11, 12. It looks like there are 12 instances of the back. I repeated back twice. I did. Thank you for noticing. Very good. So we'll see if that's actually going to come back and bother us. We'll see, maybe our chart has too much information or something like that. So we'll just kind of ignore that part of the chart. Very good. But I did count back. I did count 12 instances of back. Does that sound about right, guys? Did you count 12? I'll double check here. 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So I'm thinking there were 12 instances of the back. Next up, we can talk about the wrist. Let's see, I've got 1. Not a whole lot of wrist issues here. 2 wrist issues. And that would probably be the wrist of your worries. That's a lame joke. But it feels like today's just a good old lame joke kind of morning. So we count 2 issues with the wrist. And yeah, if I make an error or counting issue, then go ahead and just let me know. You can play along with me here. You can make your own chart on your notes if you want. Something like that is perfectly fine with me. Elbow. Let's see, we got 1. Kind of going through it. It looks like there's only 1 person who had an elbow issue. And so that's all this frequency chart is. It's just counting up how many times something happened. We'll compute the relative frequencies here in just a moment. Here in just a moment. So we had 1 elbow issue, the hip. Let's see, we'll just go through there. 1, 2 instances of the hip. Neck. Let's see, 1, 2 instances of the neck. So it looks like back issues are clearly the most prevalent. Shoulder issues, let's see, we've got 1, 2 shoulder issues, 3, 4. 4 shoulder issues, I'll double check that. Yeah, 4 shoulder issues. It looks like we're missing hand issues, so we can go let me just answer that. So we can put hand issues on here. Hand, it looks like I missed that one. I think I said hand, but wrote back. I don't remember. Of course, I'm recording it so I can go back and check. But, you know, if I'm wrong, I'm not going to admit it. Come on, guys. So hand, we got 1. Not a whole lot of hand. 2.
Oh, 2 hands.
Just 2 hand issues. And our knee issues, let's see, we've got 1, 2, 3, 4, 5 knee issues. That sounds about right. These, you know, a lot of people getting physical therapy, a lot of them tend to be maybe athletes, and, you know, you can hurt your hands pretty easily as an athlete. Now, What we can do is we can see if I missed anything, we can double check it, but this is the general process behind it. Now to get the relative frequency, we're just going to say, hey, it's basically what proportion of the entire list of injuries there, what proportion of them had back issues, what proportion had wrist issues, elbow issues, etc. So what we're going to do is we need to first count up how many total things there are up there. So back, we've got, let's see, 5 by 6. It looks like there's 30 total. Looks like there's 30 total. Another way we can confirm that is if our numbers here in the frequency column are correct, we can add them up. 12 plus 2, 14, plus 1, 15, 17, 19, 21, 25, and then 30. So yeah, it looks like it's 30. There's kind of a clunky way, but we can basically say the sum of all the frequencies is equal to 30. That's the total number. So that means we're going to come into here in the relative frequency, and we're going to do 12 divided by 30. You take, according to that formula up there, it's just the frequency in each category divided by the total number. Now, this is a calculator-friendly course, and again, I strongly suggest after a certain time in the course, I think even now would be it, you want to start bringing your calculator. And what we'll see is that the relative frequency for the back is 0.4. 0.4. You do that calculation. You could even say that's 40% if you converted that to a percent. And so 40% of the issues that the physical therapist is helping people with are back issues. The wrist, do 2 divided by 30. In this calculation, technically, we don't need to put it in the box. I'm just showing you how that calculation's done. We'll go down here. 2 over 30 is about 0.0667. We'll have to round it off at some point. It's really like the number 0.06666666, and the sixes just repeat forever and ever till the end of time. 1 out of 30. This will be the last time I show the computation. And it's going to just be like the 3s are repeating forever. So about 3.3% or so of the issues are elbow related. After that, we can see that the hand issues, that's the relative frequency of hand issues. Hip issues, a lot of 2s down there, so they're all going to have the same computation and come out to 0.0667. Shoulder issues, you can double 0.0667, or you can say that's fine. And then finally, knee issues, we'll come out to that. So again, just from visualizing it, most of the issues are back issues. We can see that now. But wrist issues were certainly a thing. Elbow issues and the like. So that's kind of what's going on here. It's a pretty straightforward chart. Really, if you can construct it yourself, there's all kinds of wonderful things you can do there. So we'll go down here and oh my goodness, look at that. It's going to keep our data on the screen. Well, that's not a whole lot of fun. So here's what I'm going to do. We'll go back up. And look at it. Now it's all nice and lined up. If you have your phone, you can just take a quick picture of the screen. I already did, because what we're going to do is we're going to turn those into bar charts. We're going to turn that data into bar charts. And it's a very straightforward process. So let's try it out. I'm gonna have to clear this off, so I'll give you about 5 more seconds to take a quick picture of that if you want. If not, I do have the information listed myself. All right. It's gone. Okay. Now what we need to do is we're going to go ahead and construct bar charts out of this. A bar graph is really straightforward. There's not a whole lot um, going on with a bar graph that is going to be mysterious to us. You're basically going to, along the horizontal axis here, along the horizontal axis, sometimes called the x-axis, what you're going to do is you're going to put the different categories. We have back, wrist, elbow, hand, hip, neck, shoulder, and knee. We're going to put them along here. And then along the y-axis, I'm going to put some labels that'll just kind of give us an idea of how high we need to draw the bars in each case. Now, I'm going to guess that most of you have probably seen a bar graph before. So it's not going to be uber surprising what we're about to see here. So I'm going to need to zoom in a little bit so I can make it nice and large for you. That should be good. That should be good. Okay. Well, maybe we'll go back one. Okay. So let's get out there and let's say we're going to put the back first, and I'm going to have to write like this. Back. Next to it, we're going to have wrist. This is cool. We might get some weird overlapping, but that's okay. We remember what the general categories were. Elbow. I might give it a little more space. Maybe something like that. There we go. Elbow. There we go. Hand. Thankfully, these are all short words, not anything too wild and crazy. Next up, we have hip. Then we're going to look at the neck. And the cool thing is for the next chart, I can just copy and paste these over. Shoulder. It's okay if it's going off screen a little bit. We know that says shoulder. And then finally, the knee. Now, along the frequency bar graph here, along the y-axis, right, Shmea, I need to put some numbers. Now, I'm not going to put every number between 1 and 12. In fact, I might not even want to end with 12. So maybe I'll count by threes. Maybe I'll count by threes. So here's 3, 6, 9. Here's 12, 15, 21, and that should do it. And I'll go ahead and label these. 3, 6, 9, 12, 15, 21. And so now I'm going to use a little bit of color. I'm going to use, let's see, first person who in the text box tells me a color, I'll use your color to make the bar chart with. What do you got for me? What do you got? What do y'all want to see? Purple, that works for me. Purple is a royal color. So we want 12 for the back. So the back's going to go 12 high. Let me get this line going. 12 high for the back. And you just make a bar like that. The bars technically don't have to be connected. So the wrist has 2. So the wrist kind of just goes up. It doesn't go all the way up to 3. The bars don't have to be connected. It's okay if they are. I don't know why the book loves to make the distinction. Oh, well, if it's connected, they're a histogram. It's like, well, okay, who cares? 1 for the elbow. For the hand, we have 2. And so I'm sure we're all pretty comfortable with a bar chart, or if we've seen it before, or it's pretty straightforward. The higher the bar, the more prevalent that specific category was. And so the bar chart's pretty useful for that. I'll go ahead and finish it out. Neck is also 2, if you recall the data. The shoulder was 4, so it's going to be a lot taller than some of the previous data has been. And the knee was 5, so it's going to be even taller than the shoulder. So something like that is what's going on here with our bar chart. And that's not too bad. That's not so bad. Constructing it from a computer, I think that's pretty cool. Now the relative frequency bar chart is going to just be like, you're going to say, really, that's all it is? Because yeah, that's exactly right. So take a little mental snapshot. I almost said Snapchat. Let's take a snapshot of what this bar graph looks like. And here's what I'm going to do. Here's what I'm going to do with that. And it's not going to be all that cool. I'm going to go, well, let's see if we can get everything on there. We're going to do something along the lines of this. And then I'll just go bring these over here piece by piece, step by step, day by day. There we go. The relative frequency, except all we're going to do is we're going to come over here and we're going to replace these numbers. We're going to replace these numbers. So, and we're going to put some relative frequencies on there. Maybe redraw this blue line that was here. And we're going to put the corresponding relative frequencies. And so they're actually just going to look like this. This is 0.1. Because you may recall that we were counting by 3s earlier on the previous chart. And so 3 out of 30 is 0.1. The next one was 6. 6 out of 30 is 0.2. So that's kind of why I chose 3 on the previous chart, was because it would translate like this here. Now this is constructing, in this case, a relative frequency bar graph basically by hand, using a computer here, using drawing tools and all that. But you don't have to do that. You can use Microsoft Excel, although the rub is we don't really get into that level of detail for this course. What we're more interested in is, hey, can you read a bar graph? Your homework might have you construct a few, but it has some really cute little tools that you're going to use. But the cool thing about the relative frequency bar graph is that as long as I use basically the same scale here on the y-axis as I did previously, the bars are going to stay the exact same height, because all we care about is how tall they are relative to each other, basically. And so that is a relative frequency bar graph. It is not the most interesting thing in the world, if we're being completely honest with ourselves, but it is definitely something that we will want to know. So moving right along, what we did a second ago, we created the bar chart, the relative frequency bar chart, bar graph, whatever you want to call it. A Pareto chart is really not that interesting. I'm not even going to waste too much time with it. A Pareto chart, simply, you just reorder the categories along the horizontal axis. You reorder them from greatest to least. So the bars look like they're slowly sloping downwards. That's it. That's all it is. It's not super interesting. So that means that the back would go first here, then knee would go, then the shoulder would go. Then you have 4 categories that all had 2 things in them to people complaining about them at the physical therapy place. So you'd put them, you could just put them in alphabetical order, and then finally you'd put elbow at the end because it was the least frequent one. That is all a Pareto chart is. It's really not worth me sitting here and rewriting it. There's just better things we can do with our time. Pareto, Pareto. So again, this is qualitative data. So the major thing I want to impart upon you is that the data itself, this is the data: back, neck, wrist, shoulder, all that. That's the data. The data is the information. The fact that we went up and we counted it, that is us adding another layer onto that data. But this is the raw data, we might call it. It's qualitative because hand is not a number and it's not a numerical thing in mathematics. It's not a quantity of something. Back, knee, hip, those are not quantitative concepts. Those are qualitative concepts. They're just qualities of things. So the data itself is qualitative. Us putting counts to it is something we're doing after the fact, if you will. So here, if we're looking at this chart, highest educational attainment in 1990 versus 2009, what you can see here, the data itself is actually this. You're basically going around, you're asking a person what was the highest educational attainment, or what is your highest educational attainment? And so the data is their response. The data would be master's degree or above, bachelor's degree, associate's degree, some college, etc. Their response to that would be the data in this case. And what we're doing then is we are just imposing numbers onto that by saying, okay, what percent of people or what frequency of people we're asking about that. Samuel asks, will these lectures be on the YouTube channel so we can go back and study and look over info a second time? Absolutely. Our very first lecture that we did with live broadcast last Wednesday, it was brought to my attention that the audio and visuals just weren't great. So that's kind of why I switched to, I use these notes here, and I work with the notes, and then I'm using a microphone today. So basically I was able to get the audio and visuals looking better. So yes, this will be available later on YouTube. The last class when we met on Monday, that is already on the YouTube channel. This one, I'll have it uploaded to YouTube sometime today. It usually takes like 2 hours for it. And then YouTube likes to filter the video, make sure there's no swear words in it. So yes, this will be on the YouTubes later on today. Good question. And the link to YouTube is right under where you found the link to this course, or to this Zoom, I should say. Okay, so again, the data is what they got, what degree they got, which is qualitative. It's just a quality. It's not a number we're putting on it. Then we are coming in and then we are counting them up after the fact. So we can ask a few questions. What percent of respondents in 1990 have a bachelor's degree? So 1990, well, be careful because there's 2 bars on here. This is called a double bar chart, or there's a couple ways you could express it. And it's useful because you can look at a specific category and you can see how it's changed. The fully solid bar is the year 1990, the striped bar is the year 2009. And we can see that the number of people, the frequency of people who have a master's degree has gone up from 1990 because look, the 2009 bar is longer than the 1990 bar. So just some interesting stuff. So let's see if we can answer the question. What percent of respondents in 1990 have a bachelor's degree? We'll go to bachelor's degree. We'll go down here to the solid bar because that corresponds to 1990. And then we'll look down here and it's between 0.1 and 0.15. It's a little past the halfway mark. Let's say 0.13. So what we can write is 0.13 for the moment, 0.13, if you will, but that translates to 13%. So in 1990, about 13% of people who responded to this survey about their highest level of educational attainment was about 13%. So 13%. And now the problem is if I scroll, it's going to take that with me. So maybe we need to do this. And hopefully you can see it somewhat. Maybe not perfectly, but that's just life sometimes. And get rid of that. That helps. Okay. So this one was 13%. We argued a second ago, and that was just reading it right off the chart, doing a conversion from a decimal to a percent. Hopefully you've come into this course armed with that knowledge. That's the goal. If there were 240 million people in 2009, how many had a high school diploma? Let's assume that this is a good snapshot of the US population. That we got a sample. We asked 1,000 people what their highest level of educational attainment was in 1990, and then in 2009. We got a sample, and we're going to assume that this information holds for the general, say, US population. So, if there were 240 million people in 2009, how many had a high school diploma? Now, this one's actually a tricky question. It's a trickier question because the number of people who have a high school diploma, well, it would be this one, but you could argue, well, also all these people who have attained higher than a high school diploma will also have a high school diploma or the equivalent, maybe a GED. So actually it's this category, this, and this category, the top 5 categories. But there's also another silly way to get around that. We can just look at the number of people who don't have a high school diploma. And so in 2009, the number of people who didn't have a high school diploma, well, just by random chance, that happens to also be about 0.13 or 13%. So that means the number of people who do have a high school diploma is 1 minus 0.13. If you think about it, we're just subtracting off the people who don't have a high school diploma. That's the people who do. And so that's 0.87 or 87% of the population that has a high school diploma. And now to actually take 87% of the population, we would take 0.87, we multiply by the 240 million. Now here's what you can do. You can just call it 240 and just realize that your answer is in millions. Or you can do it like that if you want. That's totally fine. There's nothing wrong with that. You can just put the full number at 240 million. And of course you can use a calculator. And I'm going to do it too because I am an American. I love my calculator. And that is 208 million. I need to extend the text box here. 208,800,000 people had at least a high school diploma. So this one, it's tough. If it asked for how many people have an associate's degree, well, if you have a bachelor's or master's, that doesn't guarantee you have an associate's. So if it had switched the question up a little bit, which, oh, hey, look, it's about to do that. If it asks how many people have an associate's degree, then I would just use this category in that specific case. I would just use that category. So far so good. Let's look at the last one. And I'll use a different color. How about red? If there were 186 million people in 1990, how many had an associate's degree? So now let's just focus in on the associate's degree category only. We won't try to say that bachelor's or master's degrees automatically have an associate's because that's not always true. So we'll go look at the associate's degree, and we look at the gray bar now because we're looking at 1990. We come down here, and you could call that 0.06 or 0.07. It seems like it could be in either camp. So in 1990, let's say 0.06, we'll play it conservative. 0.06 or 6% of the population in 1990 had an associate's degree. We multiply that by the 186 million, And this time I won't write out all the millions. We'll just have to work with it and see if we understand what that means. So we take 6% of that by multiplying it by 0.06 by 186. And we'll get an answer of 116, or excuse me, 11.16 million. And if you wanted, you could say that 11.16 million is 11,160,000 people. According to that. So reading a lot of these bar charts, these double bar charts even, they're very straightforward. The double bar chart, again, is great for making quick comparisons with your eye. Ooh, look, the number of people who didn't have a high school diploma went down over the 19 years between 1990 and 2009. It went down. The number of people who had a bachelor's degree went up. The number of people with a master's degree went up, or at least the proportion of the population. So that's interesting news. That just means that there's become more and more of a market for those higher diplomas. That's just kind of the case here. Moving right along, we have a pie chart. A pie chart. Now, again, you've probably dealt with these kinds of charts before. These charts shouldn't be new surprises to you. So this is a little bit review-ish, somewhat. So here's what we're going to do. A pie chart is just a circle divided into section. Each section is representing a category of data. The size of each section is proportional to the relative frequency. What does that mean? Well, that means the pie chart is cut into slices. And the larger the slice, the more that specific category kind of is represented. It takes up of the whole pie. The smaller a slice, the less prevalent that specific slice is. So the way we're going to do that is we have, say, a number of Weatherford College students were asked, do you wear a seatbelt? Or how often do you wear a seatbelt? Well, hopefully you always wear your seatbelt in your car. Please just wear your seatbelt in your car, especially if it's raining, but just do it always. I mean, there's just been so much evidence that say that seatbelts lower your risk of getting a serious injury or even passing away from a car accident. They lower your risk by a hilarious amount. Like it's just, they're so helpful. They're so necessary. So hopefully you're in the always category. Always wear your seatbelt. And look, I'm not officer safety. I'm not coming in here with some corny after school G.I. Joe message about what you should do with your life. But this is one of the few things I believe in. Otherwise, I have no beliefs because I'm just a very boring person. That's not true. I have plenty of beliefs. But I don't share them. I don't share my beliefs. In fact, I always issue a challenge at the end of the semester. I say, okay, can any of y'all guess what my political leanings are and what my religious beliefs are? And I have students that give me answers along. I've been called a Republican and a Democrat by an equal amount of students. I've been called, oh, you're this religion or you're that religion. I've been called everything because I make it clear that I don't share my beliefs about anything with you, except ironically, my belief that I don't share my beliefs with you, which is itself a belief. So anyways, long story short, yeah, I love that my students can't predict what I am because it's not necessary. It's a math course. I don't need to go off on some political rant. Although you could argue I just did because my politics could maybe be that I shouldn't share my politics. But anyways, long story short, the first thing we're going to need to do is, so the students were asked, how often do you wear a seatbelt? 2,518 said they always wear it. 1,257 said most of the time. What we're going to need to do is get the relative frequencies, which means we need to know the total number of students who answered. And that means we need to add up this category. So we will add these all together. And, in some of my math classes, we're not allowed to use a calculator, and the calculations are meant to be pretty straightforward. But here, why not just use a calculator? So 2518 plus 1257 plus 552 plus 324 plus 125 is going to give you a whopping 4,776. That's 3,000 years after they signed the Declaration of Independence. Isn't that something? So 4,776. Now, in each relative frequency, what we're going to do is we're going to take the frequency before it and divide by the total. So this first one is going to be, and then this is a little bit large. Let's go ahead and zoom in real quick. Give me 1 second. Let me zoomify, and I'll fix all that in just a moment. There we go. Now I got a little more elbow room here. So the first one, we're going to take 2518 and we're going to divide by 4,776. And it's just that simple. You can round to, say, how about 3 decimal points? And you'll get 0.527. So I'm just taking the frequency, dividing by the total in each case. I'm not going to write it in every box because space is limited. So that means that the relative frequency here, let me get it where I want it, is going to be 0.527 or 52.7%. So a little bit more than half of students, the majority of students, always wear their seatbelt, at least of the ones who were asked about that. That's not good enough. I'd like that to be darn near 100%. But whatever, I can't always have what I want in life. Because Taco Bell is not open 24 hours a day. So the next one here, we're going to do 1,257 divided by 4,776. And you can follow along with me, do these calculations yourself, 0.263. So a little over 25% of students answered that way. Next up, sometimes 552 divided by 4,776. About 11.6% of students, or I'm sorry, we're not doing percent, we're doing decimal form, so 0.116. Next up, 324 divided by 4,776, 0.068. Finally, 125 divided by 4,776, 0.026. So thankfully, the proportion of students who never wear their seatbelt is very low, but that should be 0, but it's not quite 0. So now what we need to do is we need to convert this into the pie chart that we see over here. Convert this into the pie chart. Now I'm going to use the line tool here. Someone give me another color. What's another color we want to use? I'll give you 3 seconds or I'm picking green. 3, 2, 1. Green wins. Yay, everyone say yay for green. So the proportion of students who always wear their seatbelt, that was my very bad Snape impersonation, who always wear their seatbelt is 52.7%, 0.0527. So that's a little bit more than half. A little bit more than half. And we can come in here and we can label it. Heck, I'll write a percent here now. And so that's the biggest slice of the pie. Now what we're going to do is we're going to run out of space here in just a moment. So I'll show you how you can deal with that. The next largest category, it really doesn't matter. You don't have to order it by categories. It just so happened that they went in decreasing order. But that's okay. So the next one is going to be about that large, give or take. That's always, and we'll say most, we'll just call it most. And that's about 26.3% of people if we just make that quick conversion. And now we've got only a little bit of pie left to slice up. So I'll show you how we can deal with that. The next 1.116, well, you know, maybe roughly, let's see, it's got to be more of the remainder. So we'll give it maybe that one. And maybe this one we can just sneak that one in there sometimes. Uh-oh, my lights are flickering at home. I hope I don't lose power. I should be okay actually because I'm hotspotting off my phone because my internet's down. So actually we should be okay. Yeah, the storm has knocked out some of the world today. That's okay. 11.6% for sometimes. And now you can see that's starting to get a little bit sloppy. So what we can do here is we can draw this left, and then I'm just going to draw a line, and I'm going to point to this next one. So I have plenty of space. I can put things kind of around it, and I'm going to say rarely, and that's going to be about 6.8%. And yeah, that's exactly how you can do it. Maybe I'll kind of get it out a little bit nicer like that. You can do it that way because, I mean, that's just the realism of it. If you're drawing a pie and some of the slices are tiny, there's not going to be space to write in them. You can also do a pie chart where you color code it. I could have made always orange, most yellow, sometimes red, rarely blue, and green for never, and completely fill in that pie with that color. Just completely fill it up with that color. And then go over here and make a legend. Make a chart that says yellow or orange is for always, yellow is for most. You could do it that way. Again, pie charts should not be something taking you by surprise. This is one of those common charts out here. And again, let me reiterate, I know chapters 1 and 2 of this course are a wee bit dry. They're a little bit dry, but that is life sometimes. And then finally, never is 2.6% of people who never wear their seatbelts. So yeah, that's a pie chart that we've constructed off of this. Now here's the thing, we got some questions we need to go and investigate below that. Ooh, it's gonna bring all the stuff with here. So here's what I'm gonna do. We're gonna go look at the question. What percentage of respondents answered always? Well, hey, look, it's back. Yeah. 52.7% of people answered always if we go back here and look at our pie chart. 52.7%, so a little more than half of people answered always. What percentage of respondents answered never or rarely? There we go. So never or rarely would be these. Now here's the thing. We need to add these up because it wants to know how many said either this one or that one. So it wants to know the total amount of these two slices together. Some quick math, 6.8 plus 2.6 is going to be 9.4. So about 9.4% of people answered either rarely or never. One thing I'll note real quick is normally if you were to add up all these percents, they should come out to 100%. It may not here simply because of rounding error, because in each of these we had to come over here and round. So if you added these up, because some of them you might have had to round down, some round up, you might get 99.9% or you might get 100.1%. Just keep in mind that's just because of rounding error. The true, if we were able to completely write out their percents all the way and never have to round, it would truly add up to 100% if we had that. But rounding just changes it for us. We'll go back down here. Suppose that a representative from the Centers for Disease Control says that 52.7% of college students always wear a seatbelt. Is this a descriptive or inferential statement? Ah, that's interesting. We talked about earlier in the semester, I believe back last week, we talked about the difference between descriptive statistics and inferential statistics. And the main idea was that descriptive statistics was basically just taking numbers as a whole. We were looking at an entire system. We were looking at, oh, here's everyone in America and 25% of them have high blood pressure or something like that. Descriptive statistics is the branch that just puts numbers and descriptions on things. Now, it looks like that's what we're doing here, and it is partially what we're doing, But look at this. How often do WC students wear a seatbelt? But then the problem is asking of all college students, and this is nationwide because the CDC is releasing this information. So because the question is trying to apply our information that we found here, 52.7% said always, to the entire US population, this is actually an inferential statement. We took only a sample of the population, which is just Weatherford College students. We took just a sample of it, and we're trying to say that this is true for the entire population. And that may not be the case. So what we've done is we've made inference. We've taken this information and we've inferred that it goes beyond just Weatherford College students. Are we valid in doing that? Well, that gets into some higher level statistical thought. But we can at least claim that's based on our best data, that's what we think the US population behaves like. So I would come down here and I would say this is an inferential statement. Inferential because we took information from a sample and we tried to draw inference about the entire population it came from. And so that's going to be it for the first section of chapter 2. Everyone, if you're at home, you can say yay. Yay, we've got a few minutes left. Let's jump into the next section of chapter 2. We'll jump into the next section, and now I've got it queued up. Here we go. Yay. So now we're in section 2.2, not 2.1. Chapter 2 is not super long. It's really pretty straightforward. Most people, they work the homework for chapters 1 and 2, and they say, okay, that was very straightforward. It's kind of a little bit of reading. You'll want to have your textbook handy when you're doing it. And so that's what's going on with chapter 2 as well. It's pretty straightforward. So now we're going to talk about quantitative data. And now we're actually, earlier our data was things like neck, back, shoulder. That was qualitative. We were just talking about qualities of things. Now our data itself is actual numbers. And on top of that, we're going to calculate things from those numbers. But that's the big takeaway here, is that the data is actual numbers here. And that's going to be most of the time what we're going to be dealing with for the rest of the semester. We're going to be dealing with quantitative data because it's just, I mean, this is a math class, so we got to talk about numbers, right? And so that's exactly right. But it is similar in a lot of ways to qualitative data. It just depends on what you're doing with it. So let's see, researchers are interested in determining the age at which adolescent males show the greatest growth. The age of maximum yearly growth is as follows. So what we did was we took a sample of young males, adolescent males, and we looked over their information and we figured out which year of their life did they grow the most. So this is actual data points. This 12 here represents the first adolescent male, the first boy that we talked to, that we got information for, and his greatest year of growth was when he was 12 years old. The next person, the next data point is 14. So the next person, their greatest age of growth was when they were 14, then 13, then 14, then the next person was 16. So this is the data itself. And it's pretty straightforward. The nice thing about numerical data is it can automatically be ordered. So when I go down here to fill out my frequency chart, I'm actually going to put the numbers themselves and I'm going to put them in actual order. I can put 12 here, 13, 14. I don't have to put back, neck, shoulder, which can't be ordered because is the back better than the shoulder? I don't know, no. So what I can actually do is I can fill out this frequency chart here, and it looks like the ages range from 12 to 18. And if it just so happened that there was a missing age in between, I would still put it on the chart and then just say it has a frequency of 0 so that my chart doesn't have any gaps. But let's see if that's going to happen. So what I'm going to do is I'm going to take a quick picture of the data itself so that, because I'm going to have to scroll down to see the chart. And you'll have to trust me for the moment that I'm doing it, or maybe I'll just zoom out here. That might just be what we have to do. Okay, that might be the best way to deal with it. Maybe zoom out one more little bit. Okay, so age of Max Grow, let's annotate. We'll use some text. We'll say it was 12. Next one's 13. I don't remember what year I grew the most. Probably 12 or 13. That sounds about right. 15. So we're going to put everything from the lowest point to the highest point, 16, 17, 18. Our chart has extra space on it. That's fine. Not a problem there. We see we have 7 different categories. So now we're going to do the frequencies. How many times does the number 12 pop up? Well, let's see. 1, 2, 3. Let me double check, make sure I didn't miss any. No, I don't think I did. So the age of 12 has a frequency of 3. For 13, 1, 2, 3, 4. So there were 4 boys who their best growth year was when they were 13. 14, I've got 1, 2, 3, 4, 5, 6, 7. So 14 might just be the most popular one. The age of 15, I've got 1, 2, 3, 4, 5. The age of 16, I've got 1, 2. I don't see any others. 17, I've got 1. So I've only got one person who their best age year was 17. And finally, 18 was just 1. And folks, give me 1 second. I need to check on something real quick. I'll be back in like 1 minute. Sorry about that. I had to go check on my dog, he's a full-bred bloodhound, which is pretty cool if you ask me. At least I think it is. Okay. So those were the frequencies in each category. Now we just need to do the relative frequencies. This means that we need to count how many total we have. So 1, 2, so let's see, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12 times 2 is 24. So we have a total of 24. So in the relative frequencies, we just need to go in. So this first one would be 3 over 24, which reduces to 1/8, which would be 0.125. The next one, 4 over 24, is 1/6, so we could write that. So it's not always the most exciting calculation in the world. The next one comes out to that. We'll round to 3 decimal points in each case. And we're getting some good data here, 3 decimal points. So there we go. Now we can draw a histogram of this frequency. Here's the thing, a histogram is just a bar graph where the bars touch. It's not super interesting. I think we already spent enough time on bar graphs previously. It would be the same thing. You'd have your horizontal axis, your vertical axis, your horizontal axis. You'd put the numbers here, 12, 13, 14, 15. Just draw bars above them and then just have the bars all touching so that it's like, here's the first bar. Ah, yes, thank you. Here's the next bar. They touch. There's no gaps in between them. That would be all it is. It's not all that interesting if you ask me. And that's what a histogram would be for this data. So all we did was we made the leap from qualitative data to now quantitative data. Okay, so for attendance today, we're gonna just do virtual attendance. I can see who you are, and we'll just not take it for today. Which attendance only, basically, it doesn't matter if we take it. If we don't take it, that means that it could actually hurt you if you weren't here and I did take attendance. So we're not going to worry about it. We're going to say we had a virtual meeting today and most of y'all were here, so very good. Thanks for showing up. I hope you got something out of it. Let me just go over some quick announcements. This Monday morning is Labor Day. So that's September 7th, if you saw that in my email. That's a school holiday. The school's completely closed. So we won't be holding class, but I want to get chapter 2 done. So sometime Monday afternoon, I will upload a video of myself going through the rest of the chapter 2 slides information here. And so you can expect that on YouTube. I'll upload a video of today's lecture onto YouTube. What else? Then we've turned around. We have our first exam next Wednesday, September 9th. Next Wednesday, September 9th. That exam covers chapters 1 and 2 of the course. So by Monday, you'll have all of chapter 2 at least added to YouTube, so you'll be able to watch that. You have homeworks due tonight. You have a round of chapter 1 homeworks that are due tonight on MyLabs Plus. Then next Wednesday, you have your chapter 2 homeworks due on MyLabs Plus. Plus you have your exam on MyLabs Plus. And remember, the first exam is taken on MyLabs Plus. We don't use the Respondus monitor system for it. That's going to come with exam 2. So exam 1's on MyLabs Plus. Look for an announcement about that in Canvas by tomorrow. I'll have some more information on how you can access your exam and whatnot. So no class Monday. Exam is on Wednesday, so we also won't be meeting Wednesday because you can take the exam basically during that time. So we basically will not be meeting next week at all. But I'll post a YouTube video with the rest of chapter 2. So if you guys have any questions, you can direct them to me. And yeah, you can just direct them to me. You can email me or whatever. And other than that, you guys have a great day. Thanks for coming, and I hope the roads aren't too bad.